Remember, whenever you're solving an equation that involves E, we have to get this by itself. This right here has to be by itself. This E. So we have to get rid of that 3. Now, what's happening between the 3 and the E? Are they being added, subtracted, multiplied, or divided? What'd you say, Isaiah? Multiplied, yep. And what's the opposite of multiplication? Division. Come on, Bailey, let's pay attention. We ain't got that much to do today. I'll be out your face. You can get back on your phone. So you're going to divide by 3 just like that. So go ahead and divide the 12 by 3. So you have e to the power of x minus 2 equals so go ahead and figure out what you get. So you get 4. So who remembers from last week, what is the opposite of E? How do you cancel out E? Opposite is ln, yep. So we're going to put a natural log in on both sides. All that will do on the left is cancel out E, just like that. So that exponent is not an exponent anymore. And you'll have x minus 2 equals the natural log of 4. Go ahead and type in. Type in natural log of 4. And I get 1.39. Okay. And what's my last step to solve this for x? Add 2. So this last piece of chapter 6 is just solving. And we're going to solve equations that have e's, that have natural logs, all different types of exponential and log equations. So your final answer would be 3.39. All righty. So now let's go to our notes. And go to page, what page is that? 16. So we got a formula. Before we get started, let's go through what the formula means, because you probably will see this formula on your test next week. So this is our formula right here. So it's y equals ae to the negative kt. So what do these variables represent? Let's start off with y. Y is your ending amount. That's how much you end with. A is your starting amount. We all know E is a button in our calculator. And then we have K. K is a constant used in science. That's like a scientific constant. Every element has a different K value. And then lastly, we have T, which is time. So those are our variables. Okay. So now I'm going to read the question, and we can figure out where each number, where they're going to go. It says that DDT is an insecticide used by farmers. It decays slowly and is sometimes absorbed by plants and the animals that eat them. Data shows that, okay, we got our first number, 500 grams of DDT will decay to 450 grams in 5 years. And they want us to find decay value. So what is the 500 represent? Is that my starting amount or my ending amount? The 500 is what? Start, so A is going to be 500. The 450 is what? What's the 450? The ending amount. And 5 years, that's T. And we don't know K. That's what we're trying to find. All right, so let's go ahead and substitute it in and solve it. Negative 5K. So first thing first, just like in our bell work, these two are being multiplied. I have to get rid of this 500 before I could put in the LN. So let's start off by dividing both sides by 500. So in your calculator, take 450 and divide it by 500. You should get 0.9. Okay, now, what's the opposite of E? How do you cancel out E? LN, let's put that in. So that's going to cancel this out. So now what I'll have is the natural log of 0.9 equals negative 5K. And then my last step to get rid of the negative 5 is to divide. So go ahead and pick up your calculators. Take the natural log of 0.9 and divide that by negative 5. You should get a really small number. And that's what I got. Who got that? Raise your hand if you had that. Anybody else get 0.021? All right, I'm gonna help you set up the next one and then you can solve it on your own. It's the exact same steps. Exact same steps. So again, now we have radium, which is used for cancer treatment. It decomposes radioactively. Now this is an important word, half-life. And what that means is that you're going to end with half of what you start with. So that's what that means. So we have, again, same variables. Y is your end. A is your start. T is time. And K is some constant. Whatever the constant is for radium. That's what we're trying to find. So it says radium, it has a half-life of 1800. So 1800 is time. They want us to find the K value. So this is what we don't know. That's what we're looking for. The initial value is 4,000. So notice they did not tell me the ending. They did tell me the start. So if we're looking for a half-life, what is half of 4,000? 2,000. So let's go ahead and substitute it all in. So we have 2,000 equals 4,000 e to the negative 1,800 k. All right, go ahead and solve it. Same steps as number one. Divide, put in a natural log, and divide again. Really small number. Like 0.000. Yeah, that's correct. And then give me the first three numbers after all the zeros. That's a 4,000, not a 400. It's not a log, it's a natural log. You gotta use LN. LN, not log. Let's go back. So you gotta give me, because you can't just put zero, so you gotta keep going. So you're gonna have to give me 6 numbers after the decimal. Okay, let's go ahead and work through it. First step should be to divide by 4,000. And when you divide by 4,000, because it's half-life, you should have half, which is 0.5. All right, the only thing that will cancel out E is a natural log. Cannot be a common log, it has to be a natural log. So let's put in our natural log. So now I have the natural log of 0.5 equals negative 1,800 times K. Your last step is to divide by negative 1,800. So you get a really small number. So when you get a number like this that's really small, you can't just go to the 10th place. You have to give me a lot of digits. In this example, the first 3 numbers are zeros. So we have to keep going. K equals 0. Put all 3 zeros. And then I'm going to put the 3 numbers after the zeros. It's important that you get to the actual digits. And that would be your final answer.